Okay, so here we are on the practice exam, which is an old exam I gave from the summer of 2019. Okay, in a random sample of 300 women, 45% favored stricter gun control legislation. In a random sample of 200 men, 25% favored stricter gun control legislation. Construct a 98% confidence interval for the difference between the two proportions. Okay, so we got to go back to our exam 4 notes and see which technique we're supposed to use. So here's the exam 4 notes. Here's something I think is helpful to add to the exam 4 notes. HO and H1 for the two proportions, and HO and H1 for the two independent means. I think that might help you to have that on your exam 4 notes. Anyway, so for our question, this question, notice it says P1 right here, P1 minus P2. So population proportions. So we're talking about two population proportions. We're doing number 1 here, which means we should do 2 prop Z test or 2 prop Z interval. Let's go back and see. This one is a confidence interval. So we're going to do 2 prop Z interval on your calculator. So if you get the 2 prop Z interval up, it's way down real low on the list, you'll find x1 in 1, x2 in 2, and then the C level at the bottom. So how do we do that x1 in 1 and x2 in 2? Well, you know that the ends, those are always the total number of observations, right? So that would be the 300 women and the, 200 men. Right, random sample of 300 women and 200 men. So those are the N values, number of women and number of men. So this is for the women right here, and this is for the men. The women just happen to come first in the paragraph, right? 300 women, all right, and then later comes the 200 men. So now, how do we find the X values? If you look back at the exam 4 notes, I gave some help there. So exam 4 notes, it says, if a percentage is given, like 32% of 500, then X is 32% of 500, or 0.32 times 500. So that's what we're talking about here. We have percentages. So 45%, of the 300 women, 45% favored stricter gun control legislation. So 0.45 of is times 300. 45% of 300. If you multiply that, you get 135. And then of the 200 men, 25%. So 25% of is times again, of the 200 men, that's 50. So now, put this number, this number, this number, this number into your calculator for N1, X1 N1 and X2 N2. The confidence level is 98%. Calculate. So I'm getting a confidence interval that's 0.10233, the 0.29767, which is none of these. It's not there. So there we go. It's none of these. All right, let's go to number 2. Let me erase this work and I'll go through it with you. So number 2, we're talking about, the table shows the number of households burglarized in a sample of households with dogs and in a sample of households without dogs. Right? This is the with dogs, and this is the without dogs. Do the data support the claim that the smaller proportion of households with pet dogs are burglarized? Okay, so again, the battle on this exam 4, is identification. Just there's so many tests. How do you know what's what? What'll really help you with that is carefully reading the words, especially when they say claim. What's the claim? A smaller proportion, smaller percentage of houses with dogs are burglarized. So we're clearly talking about percentages, proportions, not averages, right? Because pretty much all the problems we do are either percentages or averages. This one is proportions, which is the same thing as percentages. So let's go back. So again, it's number 1, it's 2 proportions. So we're either going to use the 2 prob z test or the 2 prob z interval. And this one has a claim, so that means I need to write HO and H1. Whenever there's a claim, it's a hypothesis test, not a confidence interval. HO, it said there, was P1 equal P2, and H1 is P1 greater, less, or not equal to P2, right? Go back here. See how it says that? HO, P1 equal P2, H1, P1, P2 with greater, less, or not equal. And we're going to use 2 prob z test. We're not going to use the interval because this is not a confidence interval. It's a hypothesis test. So 2 prob z test. Okay, so but which one is it? Is it P1 greater, less, not equal? What's it saying? Smaller percentage of houses with dogs. So the dog one is smaller. Which one's the dog one? Well, we just go in order here. The with dog, that's P1, that just comes first. Without dog, that's P2. I just take them in the order they are in the table. P1, the dog group came first, and then P2 without dog. So P1, they're saying the smaller percent is the with dogs. So it's less because the dog, and this is no dog, right? P1's the dog. The dog is less. That's what it says. Smaller when they're with dogs. So that's what's being claimed. And you know how the evidence goes. This is always weak evidence and strong evidence. And this one here is the claim. Or I can write it right here. So the claim is right there. All right, so let's do the 2 prob z test on our calculator. We do the 2 prob z test. Down on number 6, you get x1 in 1, x2 in 2. And what are those? Well, this is x1 and in 1. You know the n's got to be the bigger, huh? 21 and 208, because n's always the total number. And this is x2 and in 2. 15 and 126. Again, the n is the bigger. It's the total number. And this is a less than test. We get that from right there. So we do put those numbers into your calculator. And I'm getting a p-value equal to 0.303. So there's my p-value, 0.303. We don't have to do anything else on this one to draw a conclusion or anything like that. We're just finished right there. Okay, let's take a look at number 6 now. I'm going to jump forward here to number 6. This one is saying the table below shows the weights of 7 subjects before and after following a particular diet for 2 months. So in a before-after, where's that in our exam 4 notes? Let's go back. Oh yeah, and here's something else good to add. to your exam 4 notes. The HO and the H1, it's the same thing as it is for number 2. You know, mu1 equals mu2, and mu1 is greater, less, or not equal to mu2. Okay, so for the matched pair information. Now, see, matched pair says before, after. So any problem where you're seeing before and after, that's matched pairs. So for matched pairs, what do? Put the data in L1 and L2 and do this L1 minus L2 stored into L3 thing. So let's go do that. So this is matched pairs, specifically because we see before and after. That tells us matched pairs. And so we're going to put the data L1, L2 into our calculator. Let's do that. All right, and after you put in L1 and L2, you've got to hit second quit to get out of the table entry mode. And then you got to go L1 minus L2 stored. So the store button is over on the left side, right above the on, into L3 and hit enter. So you got to go L1 minus L2 stored into L3, and that'll put all the data into L3. That's what it's telling you back on the notes here. Right, so put the data in L1 and L2. This is for matched pairs. And then L1 minus L2 stored into L3. And then either do t-test or t-interval. We have a hypothesis test. So we're going to do a t-test now. Bring it over here. T-test. And we're going to choose data because we have a bunch of information in data. So go to t-test, choose data, and it'll ask you mu0, list, frequency, and mu0. Let's go back and see what it says on the exam notes. It says mu0 is 0, the list is L3, choose data for t-test. We don't do t-interval because we're not doing a confidence interval, but we're doing a hypothesis test, t-test. And then data, and mu0 is 0, and the list is L3. 0, list is L3, because that's where we put the data. Right here, we put it into L3. The differences, the before minus after differences, if you subtract this and get 6, subtract this and get whatever that is, 9, etc. Those are the differences. That's what's in L3 now, is all the differences before, what they weighed before minus what they weighed after. Frequency is always 1. So put that in and then choose, I didn't write out the HO and the H1, did I? All right, so we need to do that. Let me go back to the notes. So HO is their equal, H1 is mu1 is greater, less, or not equal. So let's write that. So HO is mu1 equal to mu2. H1, mu1, mu2, greater, less, or not equal. Well, how do we know? Well, it says test the claim that the diet is effective. Effective. What's that mean, effective? What does that mean that the diet is effective? Well, what does that mean if a diet is really effective? You lose weight, right? Effective means lose weight. Means your before weight minus your after weight comes out to be a positive number, like that first person, subject A. They weighed 178 before, 171 after. Subtract that, you get a positive 6, right? Before minus after should come out positive. You want the before to be greater, and you want the after to be less, don't you? You want it to go this way, because this is whoops. This is mu1, this is mu2. Let me write that a little better here. So this is mu1, this is mu2. We just take them in order. You want the before to be greater than the after. That's what effective, that's when the diet's being effective, means. Before is greater weight than after. That's what effective means. Okay, so we have to put that in here. We have to choose the greater than option on the t-test. Whatever goes here goes there. Choose the greater than and calculate. And I'm getting a p-value. Bring it over here. Getting a p-value equal to 0.049. And the significance level, you can see it right here, 0.05. So our p-value is barely less. It is. So the p is low. HO must go away. So bye-bye HO. We keep H1, which means we believe the diet is effective. The before weight is greater than the after. And this is always strong evidence, isn't it? The HO would have been weak evidence, like always. HO is always weak, and H1 is always strong. But we canceled out HO. We rejected the null, didn't we? Reject the null, sufficient, strong evidence. Right? Reject the null, HO must go away. Reject the null, sufficient evidence. The diet is effective, right? Effective diet before weight is greater than the after weight. So there is sufficient evidence to conclude that the diet is effective. There it is. There we go.